constantly these types of advertisements. And you may have noticed that they are increasingly personalized. You search for a pair of boots, maybe next thing you know, in your Facebook account, you are shown the ad about the same item that you have been searching for. It's a very, very big business. It is increasingly taking over classical ways of advertising. So this picture shows the total amount of dollars spent worldwide. And these numbers are multiplied by billion US dollars. So from 2015 to now, in the current year 2020, we see a constant increase, and the total dollars spent is more than doubled in the past 5 years. So this is projected to increase further and further. And main point of my talk is that if so much money is being spent on digital advertising, we should be doing it in the right way. We should be using these dollars wisely to reach the maximum possible profit on benefit from these advertisements. And let's continue with maybe how is it done. Typically, let's say this is an example in Facebook. If you have a product or you're a company you like to advertise on Facebook, it usually starts with finding the right target audience. So you have to maybe answer a few questions to help Facebook find the right target people for your product to advertise to them. So the questions are about what is your marketing objective? Do you want to increase awareness? Do you want to help people consider your product, or do you want to actually like sell it right away? And there are like different maybe options here that you choose. So first, maybe the high-level marketing goal. Then you are asked to choose a specific geographical area and a demographic. Maybe you want to target a specific area. I mean, this picture shows Boston, but let's say it could be Bangkok, maybe within 10 miles or 10-kilometer radius of the center of city center. Bangkok could be your target area, and you may be targeting people of age between any interval you want, and sometimes you may be targeting all genders, but depending on your product, maybe you want to just advertise to men or women. And then you specify the format, so you want an image, video, and so on and so forth. And then the next step is usually, so these questions help Facebook identify the right set of people. So from the marketing perspective, as a product owner or as a company, you just answer these questions and Facebook help you find the best possible target audience. But then there's an important question that you still have to decide. So you found your target audience, which version of the advertisement to show? What are you going to actually show to them that will get you the most profit or get you the goal that you want to achieve? So these companies are helping you find the right target, but the question is, how are you going to advertise to them? I mean, even simple questions such as this one. So you are a company selling boots, and you know this person is interested in boots. Are you going to show them this picture on the upper left corner where you just see the, a bigger picture of the boots versus something like the bottom right corner where, it's a bit smaller, the boots, but you can get to see them in, next to a pair of jeans, someone wearing it. And which one you show, although they look, seemingly similar, exactly the same pair of boots, which one you show to people can make a huge difference in the number of clicks, number of sales, and etc. So let's give a few more examples to maybe make the point more clear. You are a coffee machine company. Let's say you could show them an artsy advertisement like the bottom right corner here. Maybe that will take people's attention more versus something like the upper left corner where people get to see how this coffee machine will look like in their kitchen. And, the examples can be extended. Maybe you are going to hire a famous person, and whether you choose George Clooney versus another actress or actor would make it potentially a big difference in, again, the number of clicks and conversion and etc. again, for this particular coffee machine company, there's been many different versions of the ad. Even after you decide to hire a specific, personality from the movie world, there are still many options to sort of show to people, like which one is going to get you the most number of clicks, and conversion is still to be decided. And the main point is, although you may argue that, well, these all look the same, I mean, what is the big difference? The impact of making the right decision can be very significant. And I'll give an example here, and we will discuss maybe, which one of these ads you think will be more effective. And one thing that's important is, again, even if the difference was something as small as a few percent, more clicks or fewer clicks between two different ad versions, when you multiply it with all the money that's being spent today in digital advertising, the impact is huge. So if people are overall in the world are spending $500 billion in digital advertising, improving the effectiveness of that by 5% can be a very important thing. So to perhaps maybe make the point even more clear, there is this example where this was from the 2 elections ago, basically. The advertisement is basically about you are going to click, if you click in this, and you will enter your information, and you will be entered into a lottery. And if you win, you get to have dinner with the former president of the United States, Barack Obama. And the writing here are exactly the same. It's just different pictures are used. On the left-hand side, what you are shown is Barack Obama is at the very focus. You see him, it's very clear that it is him. And, this is maybe one of the options you could consider. In the second ad version, you see a little bit of a different picture. Maybe it's not as clear or as visible, the president, but you see maybe a more cozy family environment. You see maybe common looking folks enjoying nice time, having dinner with the president. So it looks maybe more relatable to certain type of people. So if we were in the same room, I would usually ask you to raise your hand and choose the left version or the right version. If you were to choose, which one you would go with in your ad campaign. So I don't know if the chat would allow that, but if you want to type in your choice, which one do you think is going to get more clicks, you are welcome to write on the chat, and then I will in the next slide show which one actually. Okay. So the audience is actually getting it right. So a lot of the answers are saying the right one is going to be better. There's one on the left. One answer says the left one will get more clicks. So it turns out that, and it's not a definitive thing for every single person, but when you apply it to a large number of people, it turns out that, okay, we got relatively balanced, actually 2 left votes and 3 right votes. It turns out that the one on the right received 19% more activity, more clicks, and more conversion, basically. And 19% is a lot of difference. So if before you launched this campaign, you had these 2 versions that came from your creative group, and which one, it wasn't clear, maybe there was a debate and you ended up deciding on the left one, you would have lost quite a bit of your potential conversions because of this difference of 19%. So basically everything I have said so far is saying that advertising today is done very differently. Now we are able to reach to a very specific target set of people by means of these social media companies. But even then, even when you find your right target audience, there is this question of what type of an advertisement to show to them. And the argument today I will make is that we should be using advanced techniques of artificial intelligence to make this decision. So that's going to be the main point of the talk. So, I mean, the very, very classical way would have been the creative people come up with these two campaigns, and maybe the marketing leader, the manager, and with their maybe team members, they get into a debate and then end up deciding one of these and then just launch that. They would never know how much clicks or conversion they would have gotten with other potential ad versions, and it would be just left at that. But today things are done a bit more advanced way, and what is typically used is this notion of A/B testing. And the idea here is that before we launch the full campaign, can we do a test phase where we actually show 50% of the customers or the target audience option A and another 50% option B, and look at the results. So in this case, option A ended up leading to 23% conversion. Let's say option B ended up 11% conversion. This is your test phase. Maybe you are spending 10% of your total budget during the test phase to see which of the versions will do better. And then at the end of this phase, if you see that option A is doing significantly better, the remaining 90% of your budget is going to be spent on showing just option A. And A/B testing in online advertising is done today, very commonly. And again, the test phase is done to understand which one of these is going to get more conversion, and the winner of the test phase is used from then on. But the question here is, so this approach is still much better than just deciding in our desks and launching a campaign without any testing. But can we do better with using artificial intelligence and more advanced techniques? One problem with A/B testing is, there are a number of problems I'll talk about. So one is that how to determine the length of the test phase. So I mentioned that maybe you are spending 10% of your budget on the test phase, but there is a trade-off here. So the longer is the test phase is going to be better for guaranteeing that the winner of the test phase is actually the better performing advertisement. So you want to actually do the test phase long enough that the results are coming with some level of confidence. But the longer is the test phase, of course, you are showing 50% of the people during the test phase the inferior, the worse performing version of the ad. So as a result of that, the longer is the test phase, you are losing more money in some sense. But at the end of the test phase, you have more confidence in which one is the better one. And the alternative version is to run a very short test phase so that you don't lose that much money, but then you may not have as much confidence in the winner of the test phase being the better version. And this is sort of the biggest dilemma here. How long is the test phase should be, how long the test phase should be. And the second maybe problem is that there's this sudden jump from exploration at the test phase to exploitation. So up until a certain point is reached in this campaign, we act as if we have no clue whatsoever which one of these ads will perform better. But after that point is reached, which essentially that point I'm talking about is the end of the test phase, we suddenly act as if we know with full confidence this version of the ad is going to be better than the other. So there is this very sharp transition between the state where we act as if we don't know anything to the state where we act as if we know definitely which one of these is the better performer. So the question or these issues sort of take us to this more advanced approach that basically balances or makes the switch from not knowing anything to knowing everything in a much more smooth way, and hopefully in some sense of optimality. So the modern alternative to A/B testing is known as this class of problems known as multi-armed bandits or multi-armed bandit algorithm. And I'll talk about this. Some of the details will be mathematical, so I will maybe skip some of these a bit faster, but hopefully I will give the main idea, pretty clearly. So the problem set up here is motivated by, and sort of made up scenario, but let's say there is a casino where there are these slot machines. So if you have never seen these, basically about it's a fancier way of, let's say, flipping a coin and gaining some money if you got the heads or tails right. So the slot machine is basically you pull the arm, so there is this arm here, and these things are flipping, and if certain sequences sort of maybe coming up as the flip things are stopping, you maybe make some money. So the details are not that important, but maybe think of this as a machine that maybe gives you some money each time you pull. So the argument here is that, let's say there's a casino where there are k different slot machines. We don't know which one is going to give us more money on average. We don't know the distributions. We don't know the average reward that we get from each machine. And we are asked to play in this casino using one of these machines at every time for T rounds. So every round means I'm going to choose one of these K machines and then pull the arm of that machine and see how much reward I made. And next round, I can choose a different machine or stick with the same, and so on and so forth. And the goal is to maximize the total money I receive after T rounds. So this is a great example of a problem where there is a trade-off between exploration and exploitation. Basically, the idea here is that at the very beginning, I will not know anything about these machines. So I have to take some samples. I have to choose each machine a few times and maybe see the results. And then there's still the question of, am I confident about the results I received so far? And am I confident enough that the winner of this initial test phase is going to be actually the best performer throughout this experiment? Or should I get more samples to be more confident about which one is actually giving me the best reward? Because if from the beginning you knew that this, let's say, first slot machine is going to always give you more reward, you would have picked it in all of your T rounds. The question is, how do you get some confidence or enough confidence about which one is the winner as you basically play this game? So relating to social media advertising is pretty straightforward. So instead of slot machines, now we have different versions of the ad. And at the very beginning, if you think about it, especially like in this setting where I'm basically down to a specific actor who is going to be in the ad, I'm just debating between this version versus this version and this version and maybe similar versions to this. They all look somewhat similar, but depending on what the audience likes or how they react, it can be a big difference. Again, you may see 5% difference or 10% difference between the click ratios of these ads. So the idea here is that instead of doing like a full A/B testing like mechanism where you initially do a test phase, assuming that you don't know anything about any of these, and then at the end of the test phase, just trusting that the winner is going to be performing the best forever, we should do something in between. So let's maybe not go into too much mathematical detail, but let me just say this. The main problem with A/B testing was, if you remember, during this test phase, let's say the length is 10%, you are losing money during this 10% test phase period, in the sense that you have, let's say, two versions of the ad. One of them is better than the other. So you do 10% of a test phase, which means that 5% of the time you will be actually showing the advertisement that's performing worse than something else you have. So that 5% times whatever is the difference between the click rates is your total loss. And the problem with A/B testing is your loss is proportional to your total budget, the total number of rounds you play. And the question is, can we do better than that? So if I'm spending $1 million in advertising and I'm losing 5% of that just to figure out which one of my ads is doing better, that's a lot of money to lose. So can we do better by doing a different approach? And the answer is actually we can. The difference is somewhat subtle here, maybe unless you are familiar with the notion of logarithm or like mathematical details. But if you apply a multi-arm banded algorithm, like the algorithms that people have come up with over the years for the problem, the casino problem I have discussed, you can actually reduce your lost money from something proportional to the total budget of the campaign to something much, much smaller than that. So maybe a concrete example can be a better way to see this. So let's say we have two possible ad versions, and our budget is to basically show this to 2 million people. I mean, I give the budget in terms of the number of people we are showing the ad to, depending on which social media company you are advertising in, that might be a charge that's per capita or maybe a different cost value. But let's just say we will be showing ads to 2 million people. How many of them will be getting the best version of the ad that we have? So the ones that receive the worst version, inferior version, we can think of this as lost opportunity, right? So in A/B testing, as I said, usually 10% is the test phase. So 2 million people is your total campaign. First 200,000 will be the test phase, and half of that, 100,000, will be receiving an ad version that's not the best one. But if you use a multi-arm banded algorithm, you can reduce this 100,000 people to just 5,000 and still get the same result. So put differently, in the A/B testing alternative, 100,000 people are going to be shown an ad version, which will result with fewer sales, fewer clicks, and etc. versus in the multi-arm banded version, just 5,000 people. So you are gaining significant amount of extra clicks because the 95,000 people, that's the difference between these two, are now going to be shown the better version of the ad. Let's say the difference between the two ad versions was 10%. This basically means that you are gaining an additional potentially 10,000 customers of this total base, and it can be a huge difference. Again, multiplied with all the dollars spent in the worldwide scale in digital advertising. So let's try to maybe very briefly look at what this algorithm is doing. And what I'm going to present is a special case of the bandit setup. It's the upper confidence bound algorithm. There are different versions of the algorithm. And the performance is somewhat similar from a theoretical perspective. In reality, there might be small differences. And the algorithm is basically making a stepwise selection. And the selection is based on the average click rate for version I observed till some time. So this is what you know so far about this particular ad version, how much clicks it returns. But then you are not just basing your decision on this, you are adding a term to this, which sort of adjusts over time how much confidence in the results you are getting so far that you have. So the confidence level is maybe a specific mathematical term, but maybe the interesting thing here is that it's inversely proportional with the number of times you use this ad. So what this means is that you are creating an index where one part is based on the current performance of the algorithm, and the second part is you are sort of giving a benefit of doubt to the algorithm, some extra term, and this extra term is largest for the choice that you have shown the least number of times. So the more you show a version, the less you have to add here because your confidence is pretty high. But for the versions, for the advertisement versions that were not shown many, many times, what you are saying is, well, I am observing this much reward, but I'm not confident because this was not shown enough number of times. So let me add a specifically design term here that's inversely proportional to the number of times it was shown, so that this balances nicely the maybe best case scenario reward I would be getting from this ad. And because of this additive term, the algorithm doesn't really stop pulling basically the arms or the advertisement versions that are not performing well enough until enough number of samples are obtained. So that's maybe the better way to put it. So at the beginning, it is still gonna sort of favor the ads that are not shown many times. So it's gonna be more like A/B testing. It's gonna look more to get maybe enough samples. But over time, very smoothly, sorry about this. So over time, it basically favors the ad that is performing well enough. And the transition is very smooth. So here is maybe a better picture to show this. In A/B testing, again, the main problem was that we were doing a very sharp transition from the test phase, where we act as if we don't know anything. Option A, option B, option C, however many options you have, are shown equal number of times. But at the end of the test phase, suddenly we said, okay, option A is the best performer, so we are going to show it from here onwards. That was this very sharp transition from acting as if there is no idea to knowing with full confidence which one is the winner. In the bandit algorithm, I mean, this is a simplification of what is actually happening, but I think it explains it well. The transition is much more smooth. In the very, very beginning, this is much shorter than the test phase here. We act as if we don't know anything. So each option A, B, C, are shown equal number of times. But at the end of this very short test phase, we get some confidence that A might be the better performer here. We are not confident that it is the one, and we are not saying that from here onwards only option A will be shown, but we are saying that, okay, based on what I have seen so far, A seems to be doing a little bit better. So let me show it a bit more often. So, and then in the next one, if your confidence gets better on A being the better performer, show it even more often, and then more often, and so on and so forth. And eventually it comes a point where you, most of the times, in most of your target audience, customers or members of this social media, you are showing just option A. But again, the transition is happening much more smoothly. And what is the benefit? You can still say that if option A is actually the best one, whoever receives option B or C, that's your lost opportunity. They are receiving a advertisement that's not performing as well as your best alternative. So the area that you see in option B and C, the gray area, is sort of your lost revenue, and you can see that it is much less in the bandit version as opposed to the A/B test version. So basically the difference between this area here and the gray area, light and dark gray area here, is going to be how much extra money you will be making, or how much extra customers you are getting, or how much extra clicks you are getting. So that's sort of the idea with bandit. And there are many applications of this bandit approach. Anytime you have a number of options and you don't know which one is going to perform better, you can either do A/B testing, of course, but you can get a better performance with multi-armed bandit algorithms. Can be used for web design optimization. So you have a web page that you are designing, and the question could be as simple as, should I use a color of red or blue in this particular part of the web page? You can test it using either A/B testing or, again, multi-armed bandit. You could be checking where to put a certain, maybe CMKL could be deciding between where to put the link to apply to the graduate program on the left corner versus right corner. You could actually do a test phase and decide which one is actually getting more clicks, and then based on that, keep the better performer on the web page. It could be used for recommendation systems. So you are trying to maybe, you get a new customer, you don't have much data about them, and you are trying to recommend the right product or right movies, if this is a movie platform, to them. And again, without any data, you have to test, you have to sample results and then converge on the best one. So multi-armed bandits could be used that. If you have multiple products in your company which want to run a promotion on, again, this could be used. What we are currently working with the Oishi group in Thailand, the food chain, is basically on showing the right promotion to the customers. Like some people like 10% off versus some people like, buy 3, get 1 free kind of coupons. And we are basically trying to do personalized promotions for these people. Again, using approaches somewhat similar to what I presented today, what I'm presenting today. So in the remaining bit of the presentation, let me see the time. I think I have enough time to talk a little bit about actually my work. So what we are doing here is extending even the algorithm that I presented as the upper confidence bound algorithm. So the classical banded approach is assuming that there is really no dependency between the rewards we obtain from different choices. And that's maybe because in most problems, you cannot get any information, even if there were correlations between the different rewards. But maybe more so with also the fact that this is motivated, or maybe at least the terminology is coming from a casino example, and you don't expect any type of dependence between the reward this machine gives versus the reward this machine gives, and so on and so forth. So the classical assumption is that at each time you make one decision and the reward that you obtain is entirely independent from how much reward you would have obtained if you made other decisions. But that's not true in the problems that we most likely are using the bandits approaches for. And I'll try to convince you that these are actually correlated events. So if you think about the ad selection problem, the reward that you are getting at each time can be visualized in this way. So there is a social media user. I mean, I put my picture here, but I mean, as a marketing person, you wouldn't know who this person is potentially, but it doesn't really matter. But this person is fixed. So what I am saying is that if you show me this picture and I click, I buy a product maybe, this gives you some idea about how much reward you would have obtained, or just gives you, let's say, some idea about the likelihood that I would have clicked this version or that version, and so on and so forth. There is some dependency here because the person we are talking about that we will be showing an ad to is the same person, right? Once that person is fixed and we make one decision on them, our argument is that that gives you some information, not full information, maybe, but some information about how much rewards you would have obtained if you had shown them instead of this first one, maybe the second one and third one, and so on and so forth. So we are arguing that the banded algorithm has to take into account whatever knowledge there is available about this potential correlation. And here I am showing a work that's a little bit preliminary. We have extended it recently to a sort of maybe much more general version, but this can give, I think, some idea about the approach we are doing. So what we are saying here is that how do we leverage the correlations to improve the click rate? And the argument is, again, that we assume the mean reward that we get from each choice is a function of this hidden variable xt, and that's something that is associated with the person that we are showing the ad to. So that's kind of, I mean, I use time index t, but you can visualize this as the index of the customer that we are showing the ad to. So this could be our 1 millionth customer or 100,000 customer, and so on and so forth. So let's say we still don't know anything about this person, but over time we may get an idea about maybe you know, what type of correlations exist between the rewards from one arm versus the other arm. Maybe It could be as simple as the fact that both advertisements have the same actor, and we could be maybe saying that, well, if I shown this and they click, there's at least this much confidence that they would have clicked on the second version and third version and so on and so forth. And we developed an algorithm based on this assumption for the correlated UCB algorithm. And the idea, the very high level idea is basically in this algorithm, we can do some, something that you could call as implicit exploration. And the idea is very simple. What we are saying is that if there are correlations between the click rates of different advertisements, I can get some information about some ad version even without sampling it, just leveraging the correlation. And using this, we might be able to eliminate some of the ad options much earlier than is allowed in the classical bandit algorithm. So in the classic case, there is this assumption of independence, and the only data I can get about an ad version is by showing it to people. But here, because there are correlations, I can get some, not perfect data, but noisy data about some ad versions, even without showing it. I mean, I have to still show it a number of times, but even when I am not showing it, the correlations allow me to get some information about this from the ads shown of other versions, just by saying that, well, these two versions are similar, and if I am sampling this one and get certain reward, that gives me some idea about how much reward I would have obtained from this one. And the improvements are very significant. Basically, what we are able to do is instead of basically showing every single inferior version the same number of times, which was like this logarithm of t, I'll give some maybe number examples to make it a bit clear. But this algorithm, based on correlations, leveraging correlations, is able to eliminate some of the arms much early on. And the very important benefit of this is that it allows trying more alternative versions. So the scenario I have in mind when sort of stating this is that, let's say we are actually launching a campaign. We decided on the target audience. We decided to invest some money in one of the social media companies. And then our creative team came up with 20 alternative advertisements. In most cases, 20 is too many to like try, and maybe there is some concern that along the way of trying these 20 versions, some of them will perform really poorly and you will lose a lot of your opportunity or advertisement investment by showing these poor versions. So there might be some filtering, so to speak, at the desk, saying that, well, we should reduce this 20 to 10 or 5 because, you know, again, concerns about losing too much in the test phase or too much in the path to identifying the best version. So still some of the ad versions may be eliminated even before it was shown to any single customer. And that might be bad because you never know until you test. So our algorithm is somewhat better in that sense, because even though you may have 20 versions to begin with, some of them, if they are really performing poorly, they will be eliminated far in advance, that for all intents and purposes, the cost of showing them will be negligible. So it allows you to be more liberal, let's say, in the number of choices you start with, trusting the algorithm that because of the correlations that may exist between the choices, the very poorly performing ones will be eliminated very, very soon and without any actually additional cost. And in some cases, we actually show that you have a clear winner and the algorithm is performing so well that maybe only a few people, very small number of people, are shown the version that's not the best one, let's say. So I'll give some concrete examples to maybe make this a little bit easier to understand. So here is an example with 100,000 customers to be shown an ad to, and let's say we have 3 versions to start with. In the classical A/B testing, this is basically like the left batch and the right batch are showing the number of times we have shown them not the best option of the ad, right? So there are three versions. One of them is the best one, and there is a not best one, let's say inferior version one and inferior version two. Both will be shown a certain number of times. In A/B testing, we show both inferior versions equal number of times, and those numbers are pretty substantial. If you do bandits, as I mentioned, you don't do this full test phase, assuming nothing is known. You do maybe shorter test phases, and at the end of each test phase, you gain some confidence on which which ad version is performing better. So you tend to show it a little bit more often in the next small test phase, and then so on and so forth. So you end up basically with significant improvement in terms of the number of times the inferior versions are shown. So again, the higher is these bars means that you are losing that much money or you are losing that many clicks, because the version that these people are seeing is not the best one. So the smaller is the better. So with bandits, you improve significantly this criteria, but with our correlated algorithm, you can even push it down further. And especially the second inferior version is almost never shown to anybody except maybe about 100 people of the 100,000. And the improvements are even more obvious if you have a larger campaign. So if you have a campaign with 2 million customers to be shown ads to, A/B testing is going to lead to a lot of losses because of, again, the long test phase where you assume you have no information about which ad is the better performer. So you lose all these red portions in A/B testing. If you use a bandit algorithm, right, the upper confidence bound, you get significant improvements. You reduce it to green, and this one is not even visible. I'll show in the next slide zoomed in versions of this so that we better see the comparison. And in the correlated version that we developed, this is like almost non-existent compared to what you lose in A/B testing. This is really a huge improvement in terms of basically the regret you have in showing the inferior versions of the advertisement. So what I'm showing here is the zoomed in version of the green and blue case here. And what we see is that, I mean, bandits is already much, much better than UCB. So instead of, this is like on the order of 10,000, instead of showing 60,000 a piece, in bandits, you already reduce it to just a few thousand and a few hundred for the second inferior version. If you do correlated UCB, this is again so much better, even compared to the bandit algorithm, and the correlations really help you show the inferior version significantly fewer number of times. And this is the end of the talk. I didn't want to go into too many algorithmic details, but please let me know if you have any questions I can clarify. My webpage is here where you will see some papers related to this work. And if you are thinking about maybe graduate school, and I encourage you to apply to CMKL to be part of it. Thank you so much.
Oh, thank you so much, Dr. Osman. There is some question from the audience. He asked, how can we adapt CUCB or UCB to mix of demographic, geolocation, ads, artwork selection, as well taking into account to traits of the potential population size differences of the demographic or geolocation selection? Yeah, the question is in the chat box if you want to read. Yeah.
Right, that's a good question. So one option is that, so I think that the way I understand the question is, if you knew people's maybe demographic information or location information, you could do a better job in understanding which of these ads is gonna do better. There is something called, let me type here just so that maybe it's not lost in my pronunciation. So there's a version of the bandit algorithms known as contextual bandits. I have written it here. So if you search for that, every time before you make a decision in that version, you receive a feature, a side information, so to speak. And in the ad version, it could be the geolocation information of the person you are advertising to, maybe demographic information, and then you make your selection. And in that version, it's basically much easier to do what this question is asking, the personalized advertising. You can basically say that over time, I will get samples for every single demographic that I'm targeting and every single geolocation, and I will know which ad version works best for each geolocation and which works best for each demographic. But if you don't have that information, if you are doing so-called private advertising, you are left with correlated UCB or UCB type of algorithm. And which one of these cases you are in is really a function of which platform you are using for advertising. So if you are Netflix, or if you are Facebook, let's say, and you are advertising your own product, I think you have a lot of data about people's demographics and everything. But if you're an external company and you want to advertise in Facebook, Facebook wouldn't tell you before you show the ad version the people's demographics. I think that information is private. But again, as I mentioned at the very beginning of the talk, they let you narrow down the target audience for your campaign, the geolocation and the demographic. And then within that population, you can apply our algorithm. But if you have, again, an option to sort of see one at a time every user's feature before making a decision, you should be using something known as contextual bandits that I haven't talked about today, but you can search for it. I think it should be useful. Does that answer your question, Shiva? Yeah.
Is there any more questions? You can also unmute your mic and ask questions directly to Dr. Osman also. There is another question. Is A/B testing always worse than MAB? How to decide the time length for each round T in MAB?
Oh, so I'll answer the second one first. The time length is, I mean, T is actually maybe misleading since we mentioned it as time. It's usually just the user. So at time 1, you get user 1, at time 2, user 2, and so on and so forth. So it can be, I mean, the time notion is not important. It's actually a discrete time. And usually it's so whenever you get a new customer is basically, so whenever you get to advertise to a new customer, that's what the T is standing for. So it's an index for the user ID, if you will. And A/B testing is, yes, always worse than multi-armed bandits. Like if you apply the classic bandit algorithm, your regrets, the number of times you show the inferior version, will always be on the order of log T. I mean, if you apply the right algorithm, the ones that come with performance guarantees that have been established many, many years ago. In A/B testing, there is no way but to avoid an order of T. T is capital T. I'm talking about the total number of rounds you will play this game. A/B testing always has to have a fixed coefficient of that, fixed fraction of that as the test phase. And since in the test phase, you show equal number of times the best and the worst version, you lose something on the order of T. So I can type here as regret equals on the order of T in A/B testing. And regret is always on the order of log T in math. And regret is reward lost by making suboptimal choices, let's say. Yeah. So for those who want to maybe keep this is sort of, yeah, one of the highlights of the multi-armed bandit approach.
Thank you. Is there any more questions? Well, I guess there is no more questions. All right. So, okay. So I would like to thank you, Dr. Osman, again for an inspiring and informative talk today, tonight also, and also thanks for our participants for joining us tonight. Our next talk will be held on Thursday, October 22nd by Dr. Yuji Shi. And yeah, she will be give a talk in the topic of preconditioning helps provable faster conversion in non-convex estimations and reinforcement learning. Yeah, such a long topic and very interesting. And I hope you guys will join next time. And yeah, and thank you and hope to see you all again. And oh, by the way, we Carnegie Mellon CMKL Thailand, we are accepting the fall 2021 master and PhD application now. So with the several scholarships were being offered, so please check our website and email us for more information also. So for the duration for application is from October 1st to January 15th. And for the PhD is October 1st to December 31st. If you're interested, please join our program or contact us. And thank you so much for your time. I will record this and will publish later. Thank you so much and hope to see you all next time. Thank you.
Thank you.
Thank you so much. Bye-bye.